So cubes is also a very interesting topic. Okay, easy one, but you need to visualize. All you need to do is visualization. Okay, so let's get started. Now tell me, I have a question for you. You have a thread. Okay, a thread, and you have a pair of scissors. Now you have cut the thread with one cut. How many pieces will you get? Two. Perfect. You will get two pieces. And thread is nothing but similar to a one-dimensional line, isn't it? Yes. Now if I tell you that we have a piece, let us consider this as a piece of paper. This is a two-dimensional plane. Now if I ask you to make two cuts, I have given you a pair of scissors and I ask you to make two cuts. What are the minimum number of pieces we get and maximum number of pieces we get? Minimum 3, 4. Now let us understand the logic behind this. When will we get minimum and when will we get maximum? Now if I cut this paper, okay, let us take two cases. Okay, I have rotated this paper. So we need to make two cuts, isn't it? So I will be cutting it like this. If I cut two cuts parallelly, or if I call this X direction and Y direction, I am making two cuts in X direction. Then what will I get? Minimum number of pieces or maximum number of pieces? Minimum. Perfect. So remember this thing. We will be getting minimum number of pieces when all the cuts are made in same direction. Here I have made two cuts parallel to each other in X direction. So how many pieces did we get? 1, 2, and 3. So minimum we will have 3 pieces. This will be 1, this will be 2, this will be 3. So did you understand this logic? When will we get minimum number of pieces? When cuts are made in same direction. Now when will we get maximum number of pieces? You answered me as 4, isn't it? Yes, maximum number of pieces is 4. Yeah, you can speak now. Perfect. When diagonal, okay, or I can say when two cuts are distributed in two directions. If I make one cut in Y direction, I'm getting 1, 2. Now what I will do, I will make another cut in X direction. Okay, so this cut divides these two pieces into 4, 3, and 4. So minimum is 3, maximum is 4. So when will we get maximum number of pieces? When cuts are distributed in two directions. Or you can also cut them diagonally. Then also you will be getting 4 pieces. Okay, but the logic here is when you distribute the number of cuts in two different directions, okay, you will be getting maximum number of pieces. Clear, guys? Any doubts? Easy, right? If you have any doubts, quick responses. Clear. Now, so we have discussed one-dimensional line, two-dimensional plane, and now coming to three-dimensional cube. Okay. Now, before starting, can someone tell me how many faces do a cube have? number of faces? 6, isn't it? It's not 4. Okay, it will have 6 faces. That's the reason the total surface area of a cube is, what's the formula to calculate total surface area? 6a square, isn't it? If I consider side of a square as a, the total surface area is 6a square. So a cube will have 6 faces. Perfect. Now, number of edges. What are the number of edges of a cube? 12, 12, 12, 8. Okay, I got my answer. 24. Now, what is an edge? What is the meaning of an edge? What do you call an edge is? Corner? No, edge is not a corner. Okay, so please understand the difference between edge and corner. Joining two vertices, okay, I can also say that joining two vertices, or okay, the line of intersection of two faces is called an edge. So if I consider this is top face, this is front face. Okay, now this line joins top face and front face, isn't it? This is the line common between top face and front face. So this is called edge. Okay, likewise, 1 minute. So you might be having engineering drawing, right, in your first year? Yes. So these dotted lines represent dotted lines. When will you represent dotted lines? I think hidden lines, isn't it? Yeah. So visualize this. So you will be able to visualize. Okay. So how many edges do we have? This is 1, this is 2, this is 3, this is 4. Okay, this is 5, 6, 7, and 8, 9, 10, 11, and 12. So in total, we have 12 edges. Now, so I have received answer as 8 for numbers. What are those 8? Your answer is partly right. Yes, they are said to be vertices or corners. So what is a corner? Corner is nothing but the intersection point of 3 edges. So if I consider this is a corner, isn't it? So this is nothing but intersection point of 3 edges. So how many corners do we have? 1, 2, 3, 4, 5, 6, 7, and 8. So you have 8 corners in a cube. Clear? So do you understand what are faces, what are edges, and what are corners? Yes. Okay. Now you are given a cube, okay, and you are given with a knife. You are asked to make 3 cuts. Only 3 cuts. So if you make 3 cuts, what are the minimum number of identical pieces we get and maximum number of identical pieces we get? Identical pieces. I'm talking about identical pieces. Minimum 4. And maximum 8. Okay. So okay, minimum 4. Now let's discuss when will we get minimum number of cases. Can someone tell me? You can switch on your mic and you can speak. Yes, go ahead.
All cuts are in same direction.
Perfect. All the cuts are in same direction. So let me consider all the cuts are in same direction. And how many directions do we have in a cube? Is cube a two-dimensional solid, plane, or three-dimensional solid? Yes, you will be having y, x, and z, isn't it? Cube is a three-dimensional solid. Okay. Now let us assume that I have made these three cuts in same direction. Let us say in y direction. So one cut, two cuts, and three cuts. Okay, so if I make all the three cuts in the same direction, we will be getting minimum number of pieces. Okay, so this is 1, 2, and 4. So we have total 4 identical pieces. Now coming to maximum number. So what are the maximum number of identical pieces that we can get?
8.
8. Okay, so how will you get 8? What we have to do to get maximum number of pieces? What should we do? We have discussed this. Yeah, you have to distribute these three cuts in different directions. So how many directions do we have? We have 3 directions. So distribute these 3 cuts in 3 directions. So 1 minute. Yeah. In X direction, 1 in Y direction, 1 in Z direction. Okay. So we have a cube. So 1 in Y direction. 1. This is minimum 4. Then this is maximum. So I have made 1 cut in Y direction and this cut in so how many cuts did I make? I have made 3 cuts in each direction. Now how many identical cubes did we get? This is 1, this is 2, this is 3, and this is 4. Okay, so we have 4 cubes on the upper layer and we will be having 4 cubes on the lower layer. So you will be having total 8 cubes. Clear? Ma, are you able to visualize till here? Yes. So please understand, when will we get minimum number of pieces? When will we get maximum number of pieces? Okay. Now if I say you, we have made X cuts in one direction, Y cuts in second direction, and Z cuts in third direction. What are the total number of pieces that we will get? Now, do we have to draw a cube and find the number of pieces? No, we have a formula for that. Okay, so sir, can we make max as power of 2 number of axes? Okay, let's discuss that. Okay, I didn't understand that. Okay, yeah, but let me complete this and we'll discuss that. Okay, so if I say that there are X cuts in one direction, Y cuts in one direction, and Z cuts in third direction. See, if the X, Y, and Z are equal, then you can take power of. If I say there are X cuts in one direction, there are Y cuts in one direction, sorry, there are X cuts, then you can use cube. But here, X is different, Y is different, Z is different. Isn't it? Yes, perfect. So it will be X plus 1 into Y plus 1 into Z plus 1. This is the formula, guys. X plus 1 into Y plus 1 into Z plus 1. Clear? So here the value of X is 1. So 2 into Y is 1. We have made 1 cut in Y direction. So 1 plus 1, 2, and Z plus 1, 2. So we have total of 8. So this is not required always to be cube, because the value of X, Y, and Z can be different. Clear? Any doubts? Quick responses. Any doubts still here? Quick responses, guys. Clear. So in cubes, we will be asked questions on either cutting of the cube, okay, coloring and cutting. These 8 are maximum. You cannot have more than 8 pieces by making 3 cuts of a cube. So if you remember, there is one puzzle, okay, which might be asked in your interview. Okay, you will be given a piece of cake and you're asked to make 8 pieces by using 3 cuts. Okay, I was asked this question in my Wipro interview. Okay, so that is based on this logic. Clear? So, sir, in second cube, where is Z cut? See, this is which direction? Z, isn't it? Yes. This is Y and this is X. Clear? This formula is for identical parts. Yes, identical cubes. Clear, guys? Any doubts? Quick responses. We will be talking about identical parts only. Okay, we will not be talking whether you are cutting a cube like this, cube like this. Okay, so questions will be asked on identical cubes. Yes. Yeah. Clear. So guys, can I move forward? Can I move forward? Can I move to next question or next concept? Yes. Now, I'll give you 1 minute to answer this question. We'll discuss this after 1 minute. Perfect. 26 replies. 224. Any different answer? 224 unanimous. So that should be the answer. So number of pieces into which a cube can be cut in 3 directions, making 1 minute. 5 cuts in one direction, 3 cuts in one direction, 6 cuts in second direction, and 7 cuts in third direction. Okay, many students forget to add 1. Please don't do that. Why are we adding 1? Because if you make n cuts in one direction, you will be getting n plus 1 pieces. Okay, ante kada. So if you, for example, let us take a thread. Okay, now if you make 1 cut, how many pieces will we get? N plus 1. If you make 2 cuts, you will have 1 piece, 2 piece, and 3 pieces. So if you make n cuts in one direction, you will have n plus 1 pieces. So 3 cuts in one direction, so 3 plus 1. 6 cuts are made in second direction, then 6 plus 1. And 7 cuts are made in third direction, so 7 plus 1. So 4 into 7 into 8. So 28 into 8, 64, 6, 2, 16, 16 plus 2 is, sorry, 16 plus 6 is 224. So 224 should be the right answer. Perfect. Clear, guys? So I think basics are clear to you. Okay, now. Now first answer me minimum number. If you answer this correctly, I can assume that you have got the concepts clear. Perfect. Yes, great. Now try to answer maximum. Perfect. Maximum, I got one right answer. Okay, two right answers. Maximum, I'm again, you have again forgot to add one. Please don't forget to add one. So maximum is not 13, minimum is 13. So the answers are 13 and 125. Okay, here, guys. Now let's understand this. So what is the minimum number and maximum number of pieces into which a cube can be cut by 12 cuts? So to find the minimum number, always the logic is simple. All the 12 cuts have to be made in the same direction. So you will be getting 12 plus 1 cubes, 13, 13 cubes. Okay, this is irrespective of the number of cuts. Minimum will always be n plus 1. Okay, now maximum. Now when will we get maximum number of cubes? When we distribute these 12 cuts into 3 directions. So you need to distribute these 12 cuts into 3 directions. Okay, so in algebra, there is an identity. Okay, for example, if A plus B plus C is equal to K, okay, then the product of A into B into C is always will be maximum. 1 minute. This will be maximum. When will this be maximum? Can someone tell me that? You have an identity in algebra, which you might have studied in your 12th. When A is equal to B is equal to C. When A is equal to B is equal to C is equal to K by 3. Perfect. All three are equal. So now here, now can we divide this 12 into 3 equal parts? Yes. So in that case, we will be having 4 cuts in one direction, 4 cuts in second, and 4 cuts in third. Now you have 4 cuts in one direction, 4 cuts in second, 4 cuts in third. So the total number of identical cubes will be 4 plus 1. Please don't forget to add 1 here. Into 4 plus 1. Into 4 plus 1. So those who have sent me answer as 64. Okay, I can say that they forgot to add this one. Yes or no? Antena? We have 3 students, no, 6 students who send me the answer as 64. So why did you get 64? You forgot to add this one. Please don't do that. So this will be 5 into 5 into 5. So 125. So by making 12 cuts, you can make 125 identical cubes. Clear? Yes or no? Quick responses, please. Yes. Now here I have a doubt, guys. Okay, here 12, you can divide 12 into 3 equal parts because 12 is a multiple of 3. Now what if this number is not a multiple of 3? Then how? How many of you got this question? Got this doubt? Then how to distribute? Only one? I was expecting this doubt from many others. You got it. Yeah, we will be having students who will get this doubt. So for them, we have this question. So I'll give you 1 minute. We'll discuss this after 1 minute. Minimum is 15. Perfect. Okay, 50 responses, 51, 52. Great going, guys. Maximum is 180. Okay, maximum is 180. Maximum is 180. Perfect. So let's see. Let's see what the answers are. Yeah, 15 and 180. Okay, for minimum, the logic is always simple when you make all the 14 cuts in one direction. So the total number of identical parts, identical cubes will be 14 plus 1, 15. Now coming to maximum number. Okay, now here we have 14, isn't it? Which is not a multiple of 3. Then how should we distribute? Do we have anyone with answer 175? Let me check. Yeah, we have answers with 175, 144. Okay. Okay. So in these type of questions, when this total not divisible by 3, we need to be careful. Okay. Now we have to divide this 14 into 3 numbers such that they are very close to each other. They should be very close to each other. So what are those numbers? Yeah, 5, 5 and 4. Okay, so this is one possibility. 5, 5 and 4. So I can see that these numbers are very close to each other. But I might be confident or I might not be confident about my answer. Okay, so let me consider one more case as well. Okay, so 90% I know that this will be the answer, but to be sure, let me divide 14 into 3 parts, 6, 4 and 4. Okay, so these are the two ways to divide. Yeah, 4, 4, 6 is also possible. Yes, that's why I have considered that 225. Clear? Yeah. So let's discuss. Let's consider these two cases. Now 5, 5 and 4. So then what will be the total number of pieces? So 5 plus 1 into 5 plus 1 into 4 plus 1. Okay, so this will be 36, 36 into 5, 180. Perfect. Now in this case, n is equal to, so 6 plus 1, 7 into 4 plus 1 into 4 plus 1. Okay, so 7 into 5 into 5, 25 into 7, 175. Okay, so this is less than 180, isn't it? 180 is greater than 175. So the maximum number of pieces that you will get will be 180. Okay, so by observation also, I can say that this will be the critical case. Because if you observe, these three values are very close to each other. But 662. Okay, but there is a difference of 4 ma. See, it's not two values should be equal, very close to each other. It's all about three values being very close to each other. If I take 662, then it will be 7 into 7 into 3. So 49, 49 into 3 or 21 into 7, 140. Still less than 180. Okay, so whenever you need, you have the number of cuts, okay, not a multiple of 3, please take at least 2 to 3 cases to be sure. So I can say that many of you have considered this, but in case to be sure, okay, please check for remaining cases also. It will not take much time. Clear, guys? Any doubts? Quick responses. Any doubts? Quick responses. Clear, clear. No. Perfect. Now moving ahead. What are the minimum number of cuts required to cut a cube into 343 pieces? I can say that 90% of the students go wrong. I'll give you 1 minute. So I got some, yeah. But I'm getting right answers from many of you. Cannot be determined, no. Minimum number of cuts we can determine. Okay, I will write the options that you guys have sent me. Okay, guys. So what is the minimum number of cuts required to cut a cube into 343 pieces? Now, so 343 pieces. The answers I got are 342, 18, 21, 344, and 6 and 7. 6. Okay, so but the answer is 18. Perfect. Okay, now is this question same as the previous question? Yes or no? Is this question same as previous question? No. Okay, because in the previous question we are talking about the minimum and maximum number of pieces. Okay, in earlier questions we have discussed minimum number and maximum number of pieces that you will get. But here we are asked to determine minimum number of cuts. Okay, so those who have answered me 344, they have considered 343 as cuts, not pieces. So they have added one and replied me as 344. Yes or no? Ante kada. Those who have answered me 344, they have considered 343 as cuts and they have answered 344. Okay, so this is not the right answer. Okay, because here we have 343 pieces, not 343 cuts. Now those who have answered me 342. Now, if I say that these are the minimum number of cuts required to make 343 pieces, then what will be maximum number of cuts? Or my question is, do we really have to make 342 cuts to get 343 pieces? Do you really make, okay, need to 342 cuts to 343 pieces? No, not required. Kada. Okay, these are not minimum number of what minimum number of cuts. These are maximum number of cuts. When you make 342 cuts only in one direction, then you will get 343 pieces. Okay, so the maximum number of cuts are 342. Don't get confused with minimum number of pieces and minimum number of cuts. Clear? So the answer is not 342. Is it clear now? Is this point clear? Yes. Okay, so the answer is not 342. Okay, so now let me suppose we have made minimum number of cuts. Okay, when all the cuts are distributed 3 directions. Okay, so let me consider we have X. I have made X cuts in one direction, Y cuts in one direction, Z cuts in one. Okay. Now the total number of pieces will be x plus 1 into y plus 1 into z plus 1. Clear? And it is given that this value is 343. This value is 343. Now tell me guys, okay, there is also one more identity in algebra. When a into b into c is constant, what will be the minimum value of a plus b plus c? When will we have minimum value of a plus b plus c? If it is given that a into b into c is constant, when will we have the minimum value of a plus b plus c? Perfect.
A, B, C are same.
When a, b, c are same. When a is equal to b is equal to c. Okay. So which is equal to cube root of k. Now I have to check whether this is cube root of k or not. Yes, this is a cube root of k. Okay. So I can say that x plus y plus z will be minimum when x plus 1 is equal to y plus 1 is equal to z plus 1 is equal to what is cube root of 343? 7, isn't it? Now what is asked in the question? X plus y plus z. So those who have answered me 21, okay, they have added 7 plus 7 plus 7. Okay, you are correct till here, but your answer is wrong. Okay, x plus 1 is equal to y plus 1 is equal to z plus 1 is equal to 7. So what is the value of x? 6. What is the value of y? 6. What is the value of z? 6. Okay, so what are the total cuts? So someone answered me 6. Perfect. But we are asked to calculate minimum number of cuts required, not along each side. Okay, total number of cuts. Total number of cuts will be 6 plus 6 plus 6. So 18 cuts. Okay, so if I make 6 cuts in one direction, 6 cuts in second, and 6 cuts in third, what are the total number of pieces? 7 into 7 into 7. We will be getting 343 pieces. So the minimum number of cuts will be 18. Okay, Chinmay, we have a doubt. How to solve if there is no perfect cube root? Yeah, that we will be discussing. So any doubts in this question? Quick responses, please. Any doubts? Perfect. So can I move to next question? Can I move to clarifying your doubt? Yeah, so in this question, the total number of pieces, why we have not taken 6? Why we have taken 6? Because what is 343? 343 is nothing but x plus 1 into y plus 1 into z plus 1. Okay, so we need the minimum value of x plus y plus z, not x plus 1 plus y plus 1 plus z plus 1. Okay, so x plus 1 is equal to 7, y plus 1 is equal to 7, z plus 1 is equal to 7. So value of x is 6. Yeah, 4k3. Is your doubt clear? Seven. So what will be the? It will be 6. Yeah. Moving ahead. What are the minimum number of cuts? Okay, we have 12, 2, 10, 12. Okay. Three, 343 is not maximum number of cuts, 342. So when you make 342 cuts in same direction, you will get 343 pieces. So what is the answer for this question? 12, 9, 11. Okay, let's see. Okay. So here, minimum number of cuts required to cut a cube into 120 pieces, isn't it? 120 pieces. Now in the earlier problem, 343 can be written into 7 into 7 into 7 is a cube of a number. So we have taken x plus 1 is equal to 7, y plus 1 is equal to 7, and z plus 1 is equal to 7. Whereas here, 120 is not a cube of a number. Now, so we need to apply the same logic that we have applied earlier. So what are the three numbers, okay, whose product is 120? Okay, and they are very close to each other. So we have two responses, 3, 4, 5 and 4, 5, 6. 4, 5, 6 or 3, 4, 5? 4, 5, 6, isn't it? 4 into 5 into 6 is equal to 120. Okay, so let me consider 4, 5 and 6. Yes. Do we have any other triplet? 853. Yeah. Okay, we will also consider this. 120, 8, 5, 3. Okay, I'm taking 2. If you want me to consider one more case, I'm good. Okay, so here I'm taking only these two cases. So 120 can be written as 4 into 5 into 6 in one case. Here I am considering 120 as 8 into 5 into 3. Okay, these are the total number of pieces, isn't it? So if let me consider that I have made x cuts in one direction, y cuts in second, and z cuts in third. So 120 will be equal to x plus 1 into y plus 1 into z plus 1. Okay, so same here, x plus 1 into y plus 1 into z plus 1. Okay, so let me equate x plus 1 is equal to 4. Then what is the value of x? 3. Isn't it? If x plus 1 is equal to 4, value of x is 3. Y plus 1 is equal to 5. Value of y is 4. Z plus 1 is equal to 6. Z is 5. Okay, x plus 1 is equal to 8. X 7, y 4, and z 2. Okay, now we need the minimum value of x plus y plus z, total cuts, isn't it? The total cuts will be x plus y plus z. Okay, so what is the value of x plus y plus z here? So this is 7 plus 5 in this case, and 7 plus 4 11, 11 plus 2 13 in this case. We need to find minimum number of cuts. So the answer for this question should be 12. Clear? Yes or no? So is your doubt clarified? So how to determine minimum number of cuts if a number is not a cube of some number? Yes, any doubts still here? Quick responses. Because these are the questions asked based on cutting of cubes. Now we will be entering into coloring and cutting of cubes. If asked minimum, maximum it will be 119 only. Okay, maximum will be 119, subtract 1. So if you cut 119 cuts in only in one direction, then you will be getting 120 pieces. Clear? Yes. Cube root of 120 gives 4. Then 4 plus 4 plus 4. No, you cannot do it like that. Okay, you cannot. Cube root of 120 is not 4. Cube root of 64 is 4. What is cube root of 120? It will be in decimal. Okay, what is 4 cube? It is 64. Sir, is calci allowed for exam? No. Calculators are not allowed for CRT exam. Okay. And don't worry, you will not be given any questions with more calculations. No, there will be simple calculations only. Integer part of cube root of 120, but here you cannot take integer part, kada? No, that cannot be done like that. Clear? Guys, any other doubts? Yeah, you can find near cube. Okay, so how did you get 4, 5, 6? What have you done? Okay, what is nearest cube to 120? 125, isn't it? So you have considered 5. You have divided 120 by 5. You got 24. 24 can be written as 4 into 6 and 8 into 3. So that's how you got these numbers, isn't it? Yes. Yeah. Same for 120 and 125. Clear? Yes. Moving ahead. Now here in this question, we have a cube which is painted, completely painted blue, and it was then cut into 64 smaller but identical pieces by minimum possible number of cuts. Then you need to answer this question. Okay, so you have 4 questions. I'll give you 4 minutes. We'll discuss this after 4 minutes. Okay, we'll discuss this after 4 minutes. Okay, by the way, how is this topic, cubes? Interesting, right? Super. Okay, so are you enjoying these sessions? How many of you are enjoying these sessions? Can you raise the hands, please? Only 22? No. 80. 80. Great. So can it 128? Perfect. Thank you, guys. So 148. Yeah. Now, before starting this question, I have a question for you. I have a question for you before start attempting this question. Now, it is given that a cube is painted and cut into 64 smaller cubes by minimum possible number of cuts. So what are the cuts made in? Okay, minimum 9 cuts. And how are these 9 cuts made? 3, 3, 3. So to solve this question, first you need to identify that. 3 plus 3 plus 3. Perfect. So in order to solve this question, you need to find that. Okay. Yes. So you have 2 more minutes, guys. So yes, we have 46 replies. Okay, guys, can I have your attention please? Can I have your attention please, everyone? Yes. So here, the first part. Okay, before solving this question, 1 minute, guys. Screen is getting stuck. Yeah. So before starting this question, first thing I want you to do is I want you to identify what are the minimum number of cuts required to cut a cube into 64 pieces. That should be our first step. Okay. So 64 is a cube of 4, right? So I can split into 4 into 4 into 4. Now compare this with x plus 1 into y plus 1 into z plus 1. So the value of x will be 3, value of y will be 3, and value of z will be 3. So minimum number of cuts will be 9. Okay. And these 9 cuts should be distributed among 3 equal directions. Sorry, 3 directions equally. This should be the first logic. Now, 1 minute. Okay. So if we have a cube like this, we will be making 1, 2, 3 cuts in this direction, 3 cuts in this direction. So like this. Okay. And 3 cuts in this direction. Yes. How many of you visualize this? Visualize this? Anyone? Okay. 1 minute. Yes. You have drawn it. Perfect. Okay. So this is how I will be making 64 cuts. Sorry, 64 smaller identical pieces. Now, okay. So it will be like this, isn't it? Now, first, let us identify, okay, what are the questions? How many smaller pieces have exactly 3 faces painted, 2 faces painted, 1 face painted, and no face painted? Now, first, coming to 3 faces painted. Now, can someone tell me where will we have cubes with 3 faces painted? Where will we have cubes with 3 faces painted? No, not on the edges, only corners. So the cubes at the corners will have 3 faces exposed, isn't it? So all the cubes at the corners will have 3 faces painted. Okay. So how many cubes do we have at corners? How many corners do we have? We have 8 corners. So we have 8 smaller cubes at 8 corners. So the answer for this question will be 8. And this 8, irrespective of number of pieces. If I say that the cube is cut into 125 identical pieces or 256, not 256, 216 or 343, the answer for this question will always remain same, 8. Clear? Clear, guys? Any doubts? Clear. Now, these are cubes with exactly 3 faces painted. Now, where will we have cubes with 2 faces painted? Where will we have cubes with 2 faces painted? Okay. Edges, isn't it? Exactly 2 faces painted. We will be having them on edges. Okay. Now, let me consider this edge. Okay. So, if I consider this edge, yes, we have total how many cubes along each edge? Also remember this, cubes along each edge. We have 4 cubes, isn't it? Okay, 4 cubes along each edge. So let me consider this edge. So if I consider this edge, let this be number 1, this is 2, this is 3, and this is 4. I can say that 1 and 4 are on corners, are at corners, isn't it? So 1 and 4 will be having 3 faces painted. One will have 3 faces painted, and this cube will also have 3 faces painted. So we no need to consider these cubes because we have considered them in exactly 3 faces painted, isn't it? Now these two cubes, okay, will have exactly 2 faces painted. For this cube, it is top face and front face, isn't it? So can I say that in one edge we have 2 cubes which have exactly 2 faces painted, isn't it? Along each edge we have 2 cubes which have exactly 2 faces painted. Now how many edges do we have in a cube? How many edges do we have in a cube? Yeah, so each edge is having two cubes, so 2 into 12, 24. So we will be having 24 cubes which will have exactly 2 faces painted. Okay, now if I consider this edge, okay, this cube will have front face painted and left face painted. So if I consider this edge, so this as front face painted and right face painted. So if I consider this edge, top face painted and right face painted, and so on. Okay, so each edge will be having only 2 cubes with 2 faces painted. Clear? Clear, guys? Is this point clear? Quick responses. Yes. Now one more question. Where will we have cubes with exactly one face painted? Where will we have cubes with exactly one face painted? On the, not on the middle, okay, on the surface or on faces. Okay, you will be having exactly one face painted on faces. Okay, now let us consider this front face of this cube. Now let me consider this front face. Okay, now if I consider this front face, or the corners at, sorry, the cubes at the corners will have 3 faces painted, isn't it? These 4 are at the corners, so they will be having exactly 3 faces painted. Now these cubes are on edges, so they will be having 2 faces painted. Now if you observe, we are left with 4 smaller cubes at the middle of the face, which will have exactly one face painted. This will have one face painted, one face, one face, and one face. Okay, so each face have 4 smaller cubes with one face painted. How many faces do we have in a cube? How many faces do we have in a cube? 6. So 4 into 6, 24. So now I can say that we will be having cubes with 8 cubes with exactly 3 faces painted, 24 cubes with exactly 2 faces painted, 24 cubes with exactly one face painted. Clear, guys? Yes or no? Quick responses. Any doubts still here? Quick responses, please. Okay, no doubts. Okay. Now tell me, can we have any cube with 4 faces painted? Can we have any cube with 4 faces painted? No. Okay. So you cannot have any cube with 4 faces painted. So I can say that total number of cubes Or can we have, do we have any cubes with no face painted? Yes or no? Yes. Okay. So I can say that total number of cubes exactly 0 faces painted plus cubes with exactly 1 face painted plus cubes with exactly 2 faces painted plus cubes with exactly 3 faces painted. Now what are the total number of cubes in this question? 64, isn't it? Total number of cubes is 64. Okay. Now let the number of cubes with 0 faces painted be x. We need to determine that. Okay. What are the total number of cubes with 1 face painted? 24. Cubes with 2 faces painted? 24. And cubes with 3 faces painted? 8. So 24 plus 24 is 48. 48 plus 8 is 56. So what is the value of x? 8. Can someone tell me where will be these 8 cubes? Where will be these 8 cubes? ఈ 8 cubes ఎక్కడ ఉంటాయి? Perfect. At the center of the cube. So if you remove all the cubes on the surface of this cube, internally you will have these 8 cubes, which will have no face painted because no surface of these 8 cubes are exposed. Yes. Yeah. So any doubts, guys? Any doubts till here? Quick responses, please. Clear. Now tell me, if you are given with a question like this, do we have to draw a cube or do we have to make a cube and identify 3 faces or 2 faces with 2 faces and 1 face? Do we have to draw this figure and then do the question? Not required. Okay. This is the question. You can take a screenshot of this. Not required. We have the formulas also. Okay, these questions can be solved using formulas, but I want you to visualize this and first know the concept and then we will discuss the formulas. Now let's solve this question using formulas. So I told you, irrespective of total number of pieces, okay, a cube was cut into, the answer for this question exactly 3 faces will always be 8. There will not be any change in it. Okay, now coming to exactly 2 faces, you can use this formula, 12 into n minus 2. Okay, the total number of cubes which will have exactly 2 faces will be 12 into n minus 2. Okay, now exactly 1 face painted. Okay, the formula to determine this will be 6 into n minus 2 whole square. This is for exactly 1 face, and for exactly or with no faces painted, the formula is n minus 2 whole cube. Okay, now what is n? Yeah, I have that question. What is n? N is nothing but the side of a cube, the number of smaller cubes along each edge. So how many number of cubes, smaller cubes do we have on each edge? 1, 2, 3 and 4. Here the value of n is equal to 4, or I can say the length of the side of a cube. Here the value of n is 4. So this will be 8. 12 into 4 minus 2. So 12 into 2, 24. 6 into 4 minus 2 square. 6 into 2 square. 6 into 4. So this is 24. N minus 2 cube. So 4 minus 2 cube. So answer is 8. Okay, so if you know this formula, you can solve this entire question in less than a minute, guys. Yes, clear? Yes or no? Quick responses. So when can we use this formula? Okay, if Tell about n. N is nothing but the number of cubes along each edge or along each side. How many cubes do we have along each edge or along each side? 1, 2, 3, and 4. So the value of n is equal to 4 ma. Clear? Ma, for phase 3, it will always, for 3 phases, it will be always 8. If n is different, for example, if I say that, okay, if a total cube, okay, instead of 64, if it is 125 here, what will be the value of n? N will be 5. Okay, or you can directly remember n as cube root of this. Okay, n will be equal to 5. Substitute the value of n here and find the answer. Clear? Yes. Okay. Now, if the formula is that simple, then why did we discuss the concept then? Okay, you can directly use the formula when all the faces are painted with same color. Questions will not be asked when they are not perfect cube. In CRT, it will not be asked. Okay. Yeah. Okay. Instead, you will be asked these type of questions. Now here, we have different faces painted with different colors. Okay, this is one important model which you get in CRT exams. Then when each face have different lengths, then it is not a cube, gada. It will be a cuboid, isn't it? When it is not a cube, it will be cuboid. Now, so in a cube in which one pair of faces, opposite faces is painted red, the second pair of opposite faces is painted blue, and third pair of opposite faces is painted green. So we have opposite faces painted with different colors. Now tell me, in a cube, okay, how many, what are opposite faces? Or and what are adjacent faces? How many adjacent faces do we have for a cube? Okay, so let me consider this cube first. So before proceeding to the question, okay, now this is a cube, isn't it? This is a cube. Okay, which has 6 faces. Now if I consider this top face, how many faces are opposite to top face? One, isn't it? So I can say that for any face of cube, you will have one opposite face. And how many adjacent faces do we have for a face? 4 adjacent faces. Perfect. So how do you determine whether a face is opposite or adjacent? When can you say a face is opposite, or no, like bottom face is opposite to top face? Okay, and remaining 4 faces are adjacent. How can you say that? Okay, so yeah, I have got, yeah, for all the adjacent faces, you will have one common edge for sure. One common edge for sure. For top face and right face, you have this edge common. For top face and left face, this edge common. Top face and front face, this edge. Top face and back face, you have this edge common. But for opposite faces, you will not have no common edge. So top face and bottom faces are opposite to each other. Clear? Clear, guys? Yeah, perfect. Yeah. Coming to this question. So I'll give you a 4 minutes. We'll discuss this after 4 minutes. Okay. Okay, so let's see. Now, so can we solve this question just by using formulas?
No.
Visualize. Yes. Yeah. So, okay. Now let's try to solve this question. Okay. Yeah, somewhat we can. Now there is a cube. Pair of opposite faces are painted with red. So I consider the front face and back face are painted with red. Okay. The second pair of opposite faces are painted with blue. So I will consider the top face. Okay, let me use the, okay, no issues. So these, 1 minute. Yeah, these faces are painted with blue, and okay, the third face are painted with green. Okay, so right face and left face. Now this cube is now cut into 125 but smaller identical cubes. Identical cubes ante, okay, every cube should have same dimension. See, if you observe, these cubes are of same dimension. Kada. Now, what is the first question? Okay, or what are the two questions that we can find without, like, with using formulas?
10 and 12.
Can you repeat, please?
10 and 12.
10 and 12. Okay, so I don't be solving 10 using formula. Instead, 11. I can, isn't it? Now 12 can be find out how many small cubes were there without any face painted. So what is the formula? With zero faces painted or no face painted? What is the formula that we have discussed? Yeah, n minus 2 cube. Here, what is the value of n? So we have 1, 2, 3, 4, 5 cubes along each edge. Okay, so the value of n is 5. So 5 minus 2 whole cube. So 3 cube, 27. So you will be having 27 cubes with no face painted. Okay. Now this is for 11th question, 27. Now how many small cubes? Sorry, this is for question 12, isn't it? Question 12. Now coming to question 11. How many small cubes are there with at least 2 different colors on that face? Clear? Now at least 2 different colors. At least painted. This is also similar to at least 2 faces painted, isn't it? This is also similar to at least 2 faces. Okay. Now at least 2 faces painted. What are the cubes that we have to consider? Cubes with exactly 2 faces painted and cubes with, yes, perfect. So cubes with exactly 2 faces painted plus exactly 3 faces painted. And we are not bothered about the color here. It can be of any color. So how many faces do we have with 2 faces painted? 6 into n minus 2 square, isn't it? Plus 3 faces painted, that will always be 8. So this is 6 into 9. Oh, yes, this is 54 plus 8. 62, isn't it?
12 into n minus 2.
That is for one face painted, isn't it? Oh, sorry, my bad. Yeah, exactly 2 faces painted. This formula is 12 into n minus 2. Sorry. Yeah, thank you. So exactly 2 faces painted, 12 into n minus 2 plus this will always be 8. So 12 into what? N is 5. 5 minus 2, 3 plus 8. So 36 plus 8, so 44. So you will be having 44 cubes with at least 2 faces painted. Yeah, sorry, thank you. Now I will come to question number 10. Okay, how many small cubes are there with no red paint at all? So with no red paint, Now, how can we determine the cubes without any red paint?
Total minus red paint.
Total minus red
Yes,
paint.
total cubes minus cubes having red paint, cubes with red. What are the total number of cubes? 125. Now, what are the cubes with cubes having red paint on them?
50, sir.
50, isn't it? Okay, so you will be having 25 cubes having red paint on it on front face and 25 cubes on the back face. All these cubes will be having red color painted on them. So 25 on front face and 25 on back face. So 125 minus 50, 75. So 75 should be the answer. Clear, guys? Any doubts still here? Quick responses, please. Any doubts? No. Okay. Now, how many cubes are there with only red and green on their face? So where will we have cubes with only red and green? Only red and green. You cannot have blue color painted on them. Where can we have those cubes? Please try to visualize.
Common edge of red and green. sir.
Common edge of red and green. Perfect. So if I consider this edge, so this face will be having red, and red, and these cubes will be having green, green, and green. Now, can I consider the top cube and bottom cube? Can I consider them? No, you cannot consider them because they have blue color painted on them, isn't it? Okay, so on one edge common between red and green, you have 3 cubes. Now, how many edges are common between red and green?
4, sir.
4. So 3 into 4. You will be having 12 cubes, okay, with red and green color painted on them. So this is one edge, this is one edge. So this is one edge and this is the other edge. Okay, you have 4 edges. So the answer should be 12. Now, how many small cubes are showing only green or only blue on their faces? Okay, so only green. So on this face, only green, you will be having how many? N minus 2 square, isn't it? So you have 1. Okay, 1 minute. So if I consider this green face, 2, 3, 4, 5, 6, 7, 8, 9. Okay, nothing but N minus 2 square. You have 9 faces, 9 cubes painted with only green color on one face, and you also have one more face painted with green color. So in total, you will be having 18 cubes painted with only green color. Okay, in the same way, you will be having these 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 cubes are painted with only blue color, and you will have 9 more cubes on the bottom edge painted with only blue. So total 18. 18 plus 18, you will have 36 cubes painted with either green or blue color on the face. Clear, guys? Any doubts? 13th question. Huh? Okay. Okay. In 13th question, where will you find the cubes with red and green? Okay. So I can say that if I consider this edge, which is common between the red face and green face, you will have, okay, this will be red, this will be red, and this will be red. This will be green, this will be green, and this will be green. So along each edge, we have 3 cubes, isn't it? Which have only red and only green. I cannot consider this because the top face is blue, and I cannot consider this because the bottom face is blue. In question, it is asked to determine the cubes with only red and green. Okay, so along this edge, we have 3 cubes. Okay, so how many edges do we have? 4. So 3 into 4, 12. Clear? So yeah, 14th. Any other doubts except 14th question? Okay, guys, if you do not have any doubts, you can leave. Okay, so before leaving, okay, so how is cubes? Any doubts in cubes? Quick responses. Interesting, excellent, very easy. Yes, but you need to visualize. Practice question, I will give it in the next class. Is there any concept of cuboid? Yes, but concept of cuboid is not asked in CRT. Okay, I have checked lot of questions. All the questions are based on cubes only. Good explanation. Thank you, guys. Okay. So thank you, guys. You can leave now. So the one who asked me 14th question, yeah, we'll discuss that. Thank you, guys.